Hello everyone, and welcome to the video I've made for section 8.3 on trig integrals. It's important to remember in this section that really what we're trying to do, we're going to try to take these trig integrals and we're going to try to modify them so that we can apply a substitution. And that substitution is generally going to involve either where you're going to replace u is going to be sine x, it's going to be cosine x, secant x, or tangent x. Okay, but to get going on this one, our objectives for this particular video are number one, that we want to go and we're going to solve trig integrals involving powers of sine and cosine. Their second one is we're going to solve trig integrals involving powers of tangent and secant. And the third one, we're going to look at solving trig integrals involving sines and cosines of different angles. The first ones we're going to take a look at are going to be integrals involving powers of sine and cosine. And really, so what we're looking at here are integrals of this form, where we're going to have sine to the m power and cosine to the n power. And those powers can be even or odd. They can really be any numbers, but our focus is going to be in terms of specific characteristics. Now, identities that you're going to need when working with these. Those identities are going to be, the first one is going to be where we're looking at sine squared plus cosine squared equals 1, the Pythagorean identity. And then we have these two, the power reducing, or their modification of the half angle formula as well. The idea that sine squared x is 1 minus the cosine of 2x over 2, and cosine squared x is 1 plus the cosine of 2x over 2. Be aware of when you have the exponents, and when the 2 here is a coefficient on the x. Now, when working with integrals involving powers of sine and cosine, you have three guidelines. The first guideline is really looking at when the power on sine is odd and positive. When that happens, you're going to want to go and save one factor of sine and convert the rest to cosines using the fact that sine squared x is equal to 1 minus cosine squared x. At that point, you're going to have something you're going to need to expand. So you're going to have to multiply that out and then integrate that result. But the key part is, your focus here is you're doing a u substitution. So in this situation here, what's going to end up happening is that u is going to be equal to cosine, and du then is going to be sine of u dx. And then the second identity, second guideline, really looks at when we have powers of cosine are odd and positive. You're going to save one cosine factor and convert the rest to sines using that same Pythagorean identity. Again, you're going to have to expand and integrate. And in this situation here, again, the idea is then that u is going to be sine x and du will be the cosine x dx. And number three, this is going to be where you're dealing with powers of sine and cosine that are both even. So up here, it was real easy because we could take a look at which one was odd. If both were odd, we have our choice. We can do either one. But now in number three, what's going to end up happening is that you're looking at a problem where the powers of sine and cosine are both going to be even, non-negative numbers. And so what you're going to have to do in that case, you're going to have to make repeated use of those power reducing identities. The sine squared is 1 minus cosine squared, or cosine of x, over 2, and cosine squared is 1 plus the cosine of 2x over 2. And you have to then convert that to odd powers of cosine. And then you're going to proceed as like you did in number 2. But the key part is that you might have to go through and do this multiple times. Okay, you want to get it so that you're only dealing with a constant value or odd powers of cosine when you're working with number 3. Now let's take a look at example 1 here. In this case, we're going to take the integral of sine to the 5th x cosine squared x dx. Now this one now matches up guideline 1, where we had the odd power on sine. And so what I'm going to do on this one is I'm going to go and pull out a factor of sine. I'm going to rewrite this with a factor of sine separate. So this is now going to equal the integral of sine to the fourth x cosine squared x times sine x dx. Now the reason I'm doing that, remember on this one, that this part right there, this is going to end up being du, or a part of du. In this case, it will be du, because we're going to make that change. Now the next thing I have to do at this point is I'm going to convert the sines here to cosine. So I have to remember that now is equal to the integral of sine squared x, that thing squared, cosine squared x, times that sine x dx. And replacing sine squared x with the 1 minus cosine squared, that now is going to be equal to 1 minus cosine squared x, that thing squared, cosine squared x times the sine x dx. And the next thing I have to do, remember with the guidelines that I've made that substitution, I've converted all the sines to cosines. Now I'm going to need to go and expand this. And so this will now become the integral of 1 minus 2 cosine squared x plus cosine to the fourth x times cosine squared x times that sine x dx. If I distribute this cosine squared x inside, I am going to get the integral of cosine squared x minus 2 cosine to the fourth x plus cosine to the sixth x, that whole thing times that sine x dx. And now I'm set to go and do the u substitution. So in this case, I'm going to let u equal cosine x. So du is going to be derivative cosine is negative sine, so it's negative sine x dx. I need the negative sign there and a negative out in front. And so this now becomes the negative integral of u squared minus 2u to the fourth plus u to the sixth du. And now I can go through and integrate this. That will come out to be negative. The integral of u squared is 1/3 u cubed minus 2 over 5 u to the fifth plus 1 over 6th u to the sixth plus c. Or when we go through and distribute everything, we'll get our final answer and replace the u with cosine of x. What this becomes is negative 1/3 cosine cubed x plus 2 over 5 cosine to the fifth x minus 1 over 6 cosine to the sixth x plus c. Now take a look, pause this video, make sure you follow the guidelines and how we went through and set this thing up. And if you have any questions, make sure you ask them in our next class. Let's take a look at a second example. Now in this one, it's going to match up that third criteria because the second guideline, actually we're going to end up using that second guideline in this problem. Actually we won't on this one, but that second guideline operates very similar to what we just did. The only difference is that u is going to be equal to sine x and then du is going to be cosine of x dx, and you go from there. So in this case right here, for this particular problem, and I've already done this one out, so we're not going to spend as much time with this one. So you want to pause the video, write everything down. But what we're going to have here, we're taking the integral of sine to the fourth 6x dx. So now we have an even power of sine. And so because of that, this now falls into guideline 3. So I have the integral of sine squared of 6x, that thing squared dx. And now what I'm going to do is I am going to go and use that power reducing formula. I know that the sine squared of x is 1 minus the cosine of 2x over 2. So that tells me sine squared of 6x is going to be equal to 1 minus the cosine of 12x over 2. 2 times the 6x is 12x. And now we're going to have to take that thing squared. Remembering that when we square a fraction, it's taking the numerator squared over the denominator squared. I pulled that 1/4 out, and we're here, and then we have to expand this. So when we expand it, we get 1/4 times the integral of 1 minus 2 cosine of 12x plus cosine squared of 12x dx. And then the last thing we have, now with that now, all of a sudden, we are now dealing with an even power of cosine. Again, now we're in that same situation again. So we have to go through and use that power reducing formula again, but this time only on this piece here. We don't need to worry about these two. These two pieces right there, we can integrate those. Our problem is this one. So I know cosine squared of x is equal to 1 plus the cosine of 2x over 2. So therefore, the cosine squared of 12x will be equal to 1 plus the cosine of 24x over 2. Again, 2 times 12x is 24x. And then I break that up. That's going to be 1 minus 2 cosine 12x plus 1/2 times the cosine of 24x dx. Combining the like terms, we get to here. Okay, pause the video. Make sure you're comfortable with all of this to this point. If you are, then from this point here down, we now are integrating this. So 3 over 2, the integral of 3 over 2 is 3 over 2x. The integral of negative 2 cosine of 12x is going to be negative 1/6 sine of 12x. And the integral of 1/2 cosine of 24x is going to be 1 over 48 sine of 24x. And then we have the plus c. I distributed the 1/4 inside. So I got 3/8 x minus 1 over 24 sine of 12x plus 1 over 192 sine of 24x plus c. Again, pause the video. Make sure you're comfortable with each of these. These are the easier of the two. We're going to be now moving into secants, how to deal with secants and tangents. All right, now here we are. We're going to be now looking at integrals involving powers of secant and tangent. So these are going to be ones that are in this form here, where we have the integral of secant to the mx, tangent to the nx. And again, we can have coefficients in front of those x's. That's a possibility. Now the identities you're going to have to use, these two versions of the Pythagorean identity. Secant squared equals tangent squared x plus 1, and tangent squared is secant squared minus 1. And also, as you'll see in a little bit, there might be situations where you're going to need to recall that secant is 1 over cosine and tangent is sine over cosine. Now, when you're working with these types of problems, where in the cosine and sine we had 3 guidelines, this one we have more than that. We actually have 5 guidelines. So let's go take a look at those. Here's 3 of the 5 guidelines. The first one is what happens when you're dealing with the power on secant being even and positive. Now, again, remember what we're trying to do here. We're trying to go through and set things up so we can do a u substitution and then integrate basically powers of u. Use just the integral of the power function. So in this situation here where the power on secant is even and positive, and we're dealing with secants and tangents, we know the derivative of tangent is secant squared. That's why, in this case, we're going to pull a factor of secant squared out, and then we're going to convert the rest to tangent squareds by using that identity. Again, it's going to require some expansion, probably some expansion take place, and before you integrate, before you do your substitution and you integrate. Number 2 is where the power on tangent is odd and positive. In that situation, you're going to want to save a secant x tan x factor. And we're going to convert all the rest of the tangents to secant squareds using, again, that Pythagorean identity. At that point, you need to expand and integrate. Now, the key part on this one, you got to go through and remember that you've pulled a secant x and a tangent x out. All the other ones, we're pulling out the other function. But in this case, we're pulling out secant x tan x because, again, u is going to be secant of x. So du is going to be a secant x tan x dx. Once you get through with that substitution, you expand it, integrate, make your substitution, you can integrate, things should work out. Next one, power on tangent is even and positive. We're going to go through and convert a tangent squared factor into secant squared factors, and we're going to expand that, and we're going to repeat that as necessary. Okay, that's the key part on this one. You're going to have to go through and repeat it. You may have to do that process a couple of different times. So just be aware it could, make sure get to the point where you can go and actually integrate the whole thing is really your goal on that one. So you're going to make that substitution and then expand and repeat when you have to. And because there are 5 guidelines, we do need to go to a different slide. So in this case, now we have the guidelines continued. And what's happening here, we're going to have an integral that's going to be in the form of secant to the mx dx. Now you've dealt with this. We dealt with this in class when we did integration by parts. I did the integral of secant cubed x. Okay. And I pointed out to you that was example 5. Look at this. Example 5 from 8.2. Basically, what's going to happen when you have an integral of this form where it's just powers of secant, where the power on secant is odd and positive, you're going to use integration by parts similar to what you did in example 5 from 8.2. So, and that should also be in your notes when we took the integral of secant cubed. You're going to go through, let dv be secant squared, and then u is going to be secant to the whatever m minus 2 power is. So, and then number 5. Number 5 is probably the least helpful guideline at all. Because basically what it says is if none of the 4 seem to be working, none of the 4 seem to fit, then just go and try to see what you can do, see what happens when you convert everything to sines and cosines. I.e., you're going to use that secant is 1 over cosine or tangent is sine over cosine. Make those conversions. Let's now take a look at a couple examples for these types of problems. Here we go. The third example that we have, okay, is going to be the integral here of tangent squared of 2x secant squared secant to the 4th power of 2x dx. So again, like the problem said earlier, like in this case, this is guideline 1 for these types of problems. So I'm going to pull out a factor of secant squared, and that's what I have right here. This is what I've pulled out. And remember, the reason I'm pulling that out is because that's going to be my du. That's how I'm going to end up getting this, or part of my du. So I pull that out, and now I have this. At this point, I'm going to convert the remaining secants to tangents by using the fact that secant squared 2x is tangent squared 2x plus 1. And at that point, I can distribute the tangent squared of 2x in there, and I get tangent to the 4th 2x plus tangent squared 2x times the secant squared 2x dx. So at this point now, what I'm going to do, I'm going to make my u substitution. And I know in this problem here, u is going to be tangent of 2x, so du is going to be 2 times secant squared 2x dx. When I take the derivative tangent of 2x, I get 2 secant squared 2x. And so in that case, I need that 2 there, which is going to give me that 1/2 on the outside. And at this point now, I'm set up to do the substitution. So this becomes where u is tangent 2x, that's 1/2 times the integral of u to the 4th plus u squared du, which equals 1/2 times 1/5 u to the 5th plus 1/3 u to the 3rd plus c. And when I bring back all of that, I will get to here. And when I multiply it out, I get 1/10 tangent to the 5th of 2x plus 1/6 tangent to cubed of 2x plus c. Again, pause the video. Make sure you're comfortable with everything that we have there and the calculations. If you have questions, make sure to ask. In terms of our next example, this one is going to be guideline 2, match guideline 2. So in this situation here, we're looking at the integral of tangent to the 5th x secant cubed x dx. Okay. Now, so because we have an odd power on tangent, I'm going to go and pull out a factor of secant x tan x. So that's what I've pulled out from here. That's what's here. And when I pull out the tangent x and the secant x from there, I'm left with the integral of tangent to the 4th x secant squared x times the secant x tan x dx. At this point, I now need to convert, because in guideline 2, we're going to convert the tangents to secants. So I know tangent to the fourth is tangent squared squared, and tangent squared x that's going to become the integral of the quantity secant squared x minus 1, that quantity squared, times secant squared x times secant x tan x dx. I now have to go through and expand that. I have to multiply that out. When I multiply that out, that will become the integral of secant to the fourth x minus 2 secant squared x plus 1 times the secant squared x times the secant x tan x dx. And when I distribute that secant squared inside, I will get the integral of secant to the sixth x minus 2 secant to the fourth x plus secant squared x times that secant x tan x dx. And again, at this point now, remember the process, what we're doing here is getting things set up so I can do this by substitution. U is going to be secant x, du is secant x tan x dx. And so this becomes, when I do all that substitution, this becomes the integral of u to the sixth minus 2u to the fourth plus u squared du. And when I integrate u to the sixth, I get 1/7 u to the seventh minus 2/5 u to the fifth plus 1/3 u cubed plus c. When I make them go back with the substitution, I'm going to have 1/7 secant to the seventh x minus 2/5 secant to the fifth x plus 1/3 secant cubed x plus c. And that would be the integral then of that particular function. Okay. Again, pause the video. Make sure you're comfortable with everything. I'm trying to break this down, write it out, in as much detail as possible. So hopefully we're catching everything. But if you're unsure about something, make sure you note it, and we can ask that in class next time. Now let's take a look at something very similar to guideline 3. In this case, where we're dealing with even powers on a tangent function. So tangent to the sixth of 3x dx. In that case, remember what we're supposed to do is pull out that tangent squared and convert that to secant squared 3x minus 1. So I now have, when I pull the tangent squared out, I have the integral of tangent to the fourth 3x times secant squared 3x minus 1 dx. At this point here, I'm going to distribute the tangent to the fourth 3x, and when I do that, I get the integral of tangent to the fourth 3x secant squared 3x minus tangent to the fourth 3x dx. Well, now at this point here, this one here, we're sitting there saying, oh, that's easy now. It's a u substitution. This one, though, matches the criteria again for the third guideline for the integrals involving powers of tangent and secant. So I'm going to have to pull out a tangent squared again, convert that to secant squared, and proceed from there. So when I do that, I'm going to have this part here, tangent squared 3x secant squared 3x minus, and you'll notice the brackets there, tangent squared 3x times tangent squared 3x dx, which will be then the integral of tangent to the fourth 3x secant squared 3x minus the tangent squared 3x times secant squared 3x minus 1 dx. And again, when I distribute that tangent squared in there, I now have the integral of tangent to the fourth 3x secant squared 3x minus tangent squared 3x secant squared 3x minus tangent 3x dx, or tangent squared 3x dx. And again, we have that same issue, don't we now? So I'm going to make that replacement. I'm going to replace that tangent squared 3x with secant squared 3x minus 1. And so when I do that, I get this first line in the light yellow, tangent to the fourth 3x secant squared 3x minus tangent squared 3x secant squared 3x minus the secant squared 3x minus 1, that quantity, dx. At this point, I want you to notice I did skip something here because I'm running out of space. I went through and distributed that negative sign right here. So that's where we get a plus 1. That becomes a plus the integral of 1 dx. But what I've also done here is I've gone through and broken this up into two integrals. The integrals of the powers of tangent and secant squared. That's and then I've pulled that out. so that all of this part right there became the integral of tangent to the fourth 3x minus tangent squared 3x minus 1 times the secant squared 3x dx, and then plus the integral of 1 dx, or the integral of dx. At this point, we're making our substitution. U is going to be tangent of 3x. du is 3 tangent of 3x. And so what I have to do there are 3 secant squared 3x. I put the 3 here and the 1/3 there. And I now have the integral of 1/3 times the integral of u to the fourth minus u squared minus 1 du plus the integral of dx. Now notice there's nothing happened here. There was no substitution here because that was already something we could integrate. And so when I integrate that, that becomes 1/3 times 1/5 u to the fifth minus 1/3 u to the third minus u plus the integral of dx is just x plus c. And when I distribute the 1/3 to what I have in here and go back to my substitution, I end up with 1/15 tangent to the fifth 3x minus 1/9 tangent cubed 3x minus 1/3 tangent 3x plus x plus c. Again, pause the video, make sure you're comfortable with each of those. And once you are, move on. If you're not, if you have questions, make sure you ask them in class. This last one will be a little bit faster because it's really just integrals involving sine and cosine products with different angles. And what we're going to use is the product to sum identities that you may remember from pre-calc. Okay. So in this case, so you have each of these, you got to match up which one you have. If it's the product of two sines with different angles, you're going to use this one, sine and a cosine there, or two cosines. So in this example here, we have the cosine of 5 theta, cosine of 3 theta. So what I'm going to do is I'm going to use this identity right there. And so that's going to equal 1/2 times the integral of cosine of, in this case, m is 5 and n is 3. So it's going to be 5 minus 3 times theta. So it's going to be the cosine of 2 theta plus the cosine of m plus n times theta is going to be 8 theta. D theta. And so I just need to integrate that. So that's going to be 1/2. The integral of cosine of 2 theta is going to be 1/2 sine of 2 theta plus the integral of cosine of 8 theta is going to be 1/8 sine of 8 theta plus c. Or when I distribute the 1/2, I'll have 1/4 sine of 2 theta plus 1/16 sine of 8 theta plus c. So with that, there's an example I've done of almost every one of them. The only one that we didn't do two examples. One example when we had odd powers of secant, which we have that in our previous class and when we did the integration by parts, so you can refer to that. And the other one we didn't do is one where we had to actually go and just convert everything to sines and cosines. But I think once you do that, if you get to that part, you should be fine and you'll be able to proceed from there. So with that, this does conclude this video. I hope it helps. And with that, I will see you in class.